to introduce a panel of 4 people today. The title of this session is Faster Iteration in AR Using Unity. So we have Austin, Phil, Ines, and Ciaran, and they're going to introduce themselves. So without further ado, here we go.
How's it going, everybody? Good to see you. Excited to be back here after a little while. Awesome. So I'm Phil Chacko. I'm on the product management team at Unity on the Core XR team. I've got some great speakers here kind of with me. So we're going to kind of roll through things, hopefully not keep you, I think we're right before lunch, so that's an interesting poll. So cool. So here's what we're going to cover. So we're going to talk about AR today during our time in iterating in AR. So as you know, iterating in AR is challenging using Unity. And then we're going to talk about, I'm going to pass it over to Ines and Austin from the University of Florida. And then we're going to kind of close out with Ciaran, who's going to speak a little bit about what's here and what's coming soon. So hopefully you all know and love Unity. This is the XR a creator suite that we have. So we've got a set of tools for XR developers, Air Foundation, XR Toolkit, and so on. And then we've got to make sure that you can deploy to every device that you want to be on. We've got a whole platform side to that, supporting OpenXR and others to ensure that you can get to every device that you need. Applicable, whether you're making games, whether you're making retail or entertainment experiences, or whether you're making industrial applications. So iterating AR is super challenging because you have to deal with the real world. The real world is super hard to predict. So here you might have bedrooms of different sizes, furniture of different sizes. There might be clutter. There might be a mess on a table that you might be assuming is there. There might not be a coffee table. Or you might not be considering kind of the different environments around the world where furniture might be different, layouts might be different, and so how people experience your content is going to be different. Building a device can take a while. Hopefully, if you're developing with Unity, you've probably seen various loading screens and have to deal with build time, and that can be painful. And then access to locations itself is also challenging. So the types of environments where your content is going to be experienced can include museums, amusement parks, factories, sports stadiums. These are places where, as a developer, you're not able to. You don't have your laptop, sitting at the 50-yard line, just assuming that you can kind of just test your experience there. You're kind of usually going to be in a different place, and that presents a challenge. So I'm going to pass it to Austin and Ines, and they're going to talk a little bit about an amazing project that they were able to bring to life, coming from the University of Florida.
Hi everyone, my name is Ines and I'm a software engineer in AR and VR at the Digital Worlds Institute at the University of Florida.
And hi everyone, my name's Austin Stanbury. I'm a human-computer interaction scholar at UF's Digital Worlds Institute.
So today we're presenting COVID Reflections. We implemented AR and Unity Mars to develop an interactive public art installation that gives information on COVID-19. With the goal of reducing vaccine hesitancies on UF's main campus. So the public art installation was also accompanied with a mobile clinic where students had the chance to go through our experience and then immediately take the vaccine right next to it or get a health checkup. And surprisingly, we estimated that about 1/3 of the students who went through our experience visited the clinic unit after that, and actually got the vaccine or a health checkup. And now I'm going to show a video of what COVID reflections look like.
COVID particles enter your body, they begin to attack your respiratory system. The virus may impact your nose, throat, and lungs at this stage. Within the next 2 weeks, you may experience immune response to the virus, including coughing, fever, and congestion. You may also experience neurological symptoms like loss of smell and taste. For many, COVID symptoms may end at this point. For some, more serious symptoms may occur. When COVID severely impacts the lungs, it can make breathing difficult, cause pneumonia, and cause fluid to collect in the lungs.
So for our public art installation, one thing that we really wanted to focus on is engaging the public in a creative, interactive, and fun way. And for that, we used body tracking, avatars, and FAQs. So for the body tracking portion, we used a large display that shows a virtual mirror of the user. And then the virtual avatars copies the movement of the user, as you saw in the video, and copies everything they do in front of the screen. And then it shows the effect of COVID on the body, and especially on the lungs. So it takes the user through the whole experience of first contracting COVID to the worst case scenario, and also shows the effect of getting the vaccine. And the last section of our app is an FAQ section that we developed. And virtual buttons will show all around the user, and they can reach out and touch them in the air. And each button will show an answer to a frequently asked question.
Absolutely. So now that we've kind of seen COVID reflections in action, we just want to kind of talk about why we believe that AR in conjunction with AI are really powerful tools for addressing public health issues. So, one of our primary motivations was to explore how these technologies can be used in addressing public health crisis or issues, or just providing information in general. Obviously, we've all seen amazing implementations of artificial intelligence and AR in public health, but comparatively few have focused on providing public health information to mass general audiences in public settings. COVID Reflections employs body tracking features to demonstrate how AI and AR can be used together to address the public in really powerful new ways. In this regard, we were really seeking to engage the public in a deeply personal way by using AR to place the user in the medium, thereby giving them a virtual first-hand experience of COVID-19. And lastly, we wanted to build an experience that was fun for the user. Something we really didn't expect, in fact. Our initial intention was just to provide public health information in a novel and engaging format. What we didn't expect is how much users would enjoy engaging with and playing with the body tracking functionality that we developed in our application. And in the end, we actually felt that the fun aspect of our application was what really drew users in the most, kept them engaged, and thereby allowed us the avenue to inform the user while they were engaged with our application. So, how did we build it? Well, the body tracking functionality was accomplished using Unity Mars over the iPhone 13. We took advantage of the LiDAR features of the iPhone 13. And this allowed us to vastly simplify the work of deploying body tracking functionality in our app and really sped up our development process. It also allowed us to implement a user interface that was intuitive and motion-based, allowing users to interact with UI elements just by reaching out and touching them with their hand. Furthermore, during the development process, Features of Unity Mars, including the synthetic data and simulation, allowed us to test our application without deploying to the device, and really helped us as we navigated the development process. Obviously, it can be pretty complicated to test these applications without, lots of user data, et cetera. So those functionalities were extremely important for us.
So this is a picture of the virtual environment from Unity Mars, and it was really our best friend in the development process because we didn't have to build to the device each time we wanted to test something, and that takes a very long time. So this really reduced our workflow by a tremendous amount.
And lastly, we just want to comment on the art direction of our application. Obviously, as a public health art installation, this was a very important aspect for us. The environment and the virtual architecture assets that we used were developed by our team member, Erica Del Hagen. Unfortunately, she wasn't able to make it with us today. But she developed it in an architectural 3D workflow program called Revit. All of the custom assets that we developed were modeled and textured with Substance Painter and Maya. So those sort of our classic workflow. And the custom effects, especially the effects demonstrating the impact of COVID-19 on the body, were developed with the URP shader graph along with Unity's animation functionality. And that really allowed us to achieve some interesting effects, showing COVID on the lungs and whatnot, and sort of creating abstract visualizations that help users connect with the information and understand what's happening to their bodies.
And for the future direction, we really hope to expand COVID reflections to include all sorts of public health challenges. And if anybody is interested in learning more about our work, please talk with us after this panel.
Thanks so much. So I think now we'll hear more from the Unity team here.
Hi. It's really awesome to see what you were able to do with Mars. My name's Ciaran. I'm an engineering lead on the XR team at Unity, and talk about where we are and what's coming soon. That is what our current advanced workflows are. That's Unity Mars and AR Companion, and talk a bit more about simulation, which you just saw in Code Reflections. Our existing advanced workflows built on top of the cross-platform bedrock of AR Foundation are Unity Mars and AR Companion app. Let's play, yes. Unity Mars, launched in 2020, is a set of specialized tools for AR creators aimed at helping them overcome the challenges of authoring for dynamic physical environments. It provides a flexible layout framework for defining your content in relation to the properties of the physical world and to other content, and an integrated simulation system so you can offer, edit, and test your content all within the Unity editor.
Ciaran, I'm sorry to interrupt, but get a little closer to the mic.
Oh, okay, sorry. And of course, we just heard how the University of Florida used Mars to build their COVID Reflections project. In February this year, we made available our AR Companion app, allowing you to capture and edit AR scenes directly on your mobile device. These scenes can then be saved to the cloud and synced to Unity Editor for further iteration. But what if you don't want all that? One of Unity's strengths is the speed for which you can iterate in the editor. But unfortunately, as Phil mentioned, that's not been available to AR developers, who still have to build and deploy their app to a device in order to test it. Well, we have a couple of things coming up to help developers iterate faster when building apps with AR Foundation. First, we're working on a remoting solution to allow you to stream AR data from your device to your app running in the editor. Secondly, we're bringing AR simulation out of Mars and making it available to all AR Foundation developers, allowing them to test their scenes against a variety of physical world scenarios with no device required. AR simulation is built on our XR SDK framework, so it appears to developers as just another platform which AR Foundation builds upon. So you just see it in the XR plugins dialog, just another checkbox. However, its platform is available in the editor, so enabling the edit and just press play enabling the edit and just press play iteration platform that that Unity developers love. Here is an example of the workflow. The AR simulation loads a prefab of an environment as a proxy for the real world and lets you navigate through it with a virtual device. As you go, it detects planes, point clouds, tracked images, performs raycasts, etc., just as you would on device. We provide a variety of pre-built environments reflecting different potential AR scenarios, such as indoors, outdoors, domestic, and commercial. You can also build your own, either through traditional modeling or using a scan of a real space. AR simulation will treat any meshes in your environment as real physical surfaces and detect AR features on them. Image marker-based workflows are also supported by adding a marker and tagging it as a tracked image in your prefab. And now I'm going to pass back to Phil to wrap up.
Thank you, Ciaran. So excited to say if you download the latest AR Foundation pre-release package, that you can try out simulation today. That's something that is currently available. You can try out, get the simulation system running directly in the Unity editor today for free, which is exciting. AR Foundation, it supports Unity 2021 and above, have to be at least in 2021. There are some limitations. This is a pre-release, so we've got certain subsystems enabled. We've got planes, image markers, and meshes. Additional subsystems are in development, including body tracking, which the team from the University of Florida was able to make a ton of great use of. So hopefully we showed you a little bit of kind of what you're able to accomplish, the problem of developing developing content that's experienced in the real world, being able to an example project of how you can create an impact in public health using some of these technologies, and then now talking about going forward, what you can expect in terms of trying to create this type of content. And now we've got some time for Q&A. So I think we've got a couple microphones over here. So if you don't mind stepping up to the mic, then we can get that on the recording. So yeah.
Hey, thanks so much for the presentation. I wanted to ask about creating these applications for public health. With the sort of growing conversation with like the CDRH, FDA around like VR applications and regulatory control, how is Unity sort of approaching that conversation, especially when you're dealing with maybe a partner that's more in a research setting, and also with the sort of world of NDAs? How do you find yourself sort of navigating that today? Got it.
I don't have, I'll have to say we're not exactly the right team to answer that specific question. I would say that the way we intend some of the core platform tools to be used are in the development workflow. And so in terms of the final application and using it in sensitive environments and situations, that's something that you'll probably have to talk to our digital twins team. But if you can, happy to get you in touch with folks kind of after. But yeah, that's a good question. Unless you have anything to add to that. Yeah, cool. Cool.
Do you have any plans of integrating the computer camera as an AR camera in AR Foundation?
Great question. So this is something that is possible today. It does come with some caveats. Batteries are not included. You can you can write your own OpenXR plugin. You can write your own Mars provider plugin as well, and that's something that's available right now. We've shown workflows in the past that have face tracking enabled directly in a desktop editor. But unfortunately, at this time, I can't recommend any specific providers for that. But if you're willing to do a little bit of, if you've got your own providers, you've developed your own, or you want to use a third party, it's totally possible to do that with a little bit of work.
Hi. So my question is about the body tracking features that you talked about, and will that include hand tracking as well for hand pose recreation?
Yeah, so that's a great question. So we got another talk coming up on Friday to talk about Expert Interaction Toolkit, and the latest would be Doreen's here in the audience, product manager for that. So hands are something that are increasingly important and going to be super important kind of going forward. We have plans in development around hands, particularly around interaction, that might touch some of these workflows a little bit, but more to come on that. So stay tuned. Anybody else? Cool. Thanks everybody. Yeah. So have a good day. Hopefully have a good lunch, and talk to you soon. We'll be here around front answering questions.